This is project 6 of Hacking with Swift, in which we'll do another technique project, this time looking at auto layout in more detail. For more information, please see the website hackingwithswift.com, where you can buy this and the entire series as ebooks to download and read immediately, containing far more information, plus high-resolution videos to buy as well. You can also follow me on Twitter. I am @2straws, and if you have problems or questions or want to say hello, want a new friend, get in touch and I'll do my best to help you. So we already made project 2. Here it is on my desktop. I want you to copy that somewhere. So you've got a safe copy, a backup of what you made, that flags game in project 2, and then rename it to be project 6A. We'll make 2 brief projects here because it's a technique project looking at auto layout. And the first one will be 6A, in which we'll use auto layout to fix our flags game. Specifically, the problem with the flags game is that it looks great in portrait, but very bad in landscape. Let's have a look exactly how that works now so you can see exactly how bad it is for yourself. So open up the project 6A folder, which is just project 2 really. Then double click to launch Xcode. Then I've got iPhone 4S chosen here, just fine. Choose whatever suits you and press play. There is our existing auto layout, by the way, our rules, our constraints. It will run in the 4S. There are my flags. Not brilliant spacing, but not bad. It certainly works. If I rotate to landscape, though, which is done by going to hardware, then rotate left or right, which is a command followed by the left or right cursor key. I'll rotate to the right, and you'll see, wow, we actually lose a whole flag. Now, fortunately, the answer is US, which is smack in the middle no matter what, but on the 4S, landscape just doesn't work. It might be the case that perhaps a 6 Plus maybe just makes it squeeze in, maybe just. Let's have a look. Press play in the 6 Plus and try that in landscape. And the answer is, wow, it's big, the 6 Plus. Let's scale it down slightly. Still doesn't fit. Even on the vast expanse of the iPhone 6 Plus screen, our app does still not work in landscape, which is very poor. So we want to fix that if possible. So let's go back to 4S again, so it's a bit easier to see what's going on. There we go, 4S. So we want to fix it so the app looks and works great in portrait or landscape. Portrait, landscape should both work really well. Now we have 2 options here. We could take the cheaty option, which is to lock the application to be portrait only. We can say, forget landscape. These suckers can play the game in portrait. To do that, go to the project here and then choose general and look for the orientations. And you can just disable landscape left and right, and that will stop it from rotating. That is one way around the problem. But that is the broken way around the problem, because people like to have their apps running in more than one orientation. Apps generally should rotate. This is not true of games. Games frequently, if not most of the time, do tend to lock to one orientation. A car racing game would look a bit strange in portrait, for example. So fine, you can lock your games to one orientation. But for apps, you do want to try your best to make it rotate successfully. And this is not hard to do thanks to the magic of auto layout. We're not going to write code here. We're going to fix this thing just by adding more auto layout rules. So go ahead and open main.storyboard in the interface builder. This is the same storyboard we had before. So flag 1 centers horizontally. Its width and height come from the flag. It's got a spacing here. What did I enter? Let's have a look. Of 36. And then another space between second and first flag of 30, and another one of 30. I could make these all the same perhaps, just to really make it slightly more equal. Let's put in 30 there as well. Fantastic. But those are our rules. Center the flags horizontally and space them out 30, 30, 30. That's fine. We want to first make sure the bottom flag is also at least 30 away from the bottom. So this gap here and this gap here are the same. It looks rather uneven right now in a 4S. This is not very hard to do, fortunately. We can control drag from the bottom flag straight down the way into the space here in this view controller area. Then let go of the mouse button and choose bottom space to bottom layout guide. Boom. that creates a new constraint. Now this constraint is interesting because we now have a complete set of vertical spacing. This one here says it should be 30 away from the top layout guide, i.e. the navigation bar. This one should be exactly that far from that flag, this one from that flag, and also that far from the bottom, which means if our view controller is not that size, this number will not add up correctly, because it's 30 plus 30 plus 30 plus, what's this last one? 114. So right now it's a very precise thing. So it's valid, it's perfectly valid, it's a perfectly valid layout, but your view controller has to be exactly that size, otherwise it's not going to work. So we play that back inside the iPhone 4S. Look at that. This flag, this bottom US flag, has got massively squished because it's done its best to honor the auto layout rules. It said, well, listen, if you want that to be 114 space, well, I can do that for you, but only by squishing a flag, which does not look very good. So it's valid, but it's not great because it will screw up your layout. It doesn't work for us. Now, what will happen here is it adds up this number, the gap, this number, the gap, this number, the gap, and this number, the gap. So 30, 30, 30, 114, adds them all up and says, well, okay, I know the total of that. The remainder, that's how much space I have to divide amongst the three flags. And it's doing its best. It's saying, well, I can make the first flag full size. That makes that flag happy. I can make the second flag full size. Hooray, it's still happy. But the third flag, sorry, there's not enough room for you in an iPhone 4S, so I'll squeeze you. There isn't enough space for it. And that's a compromise. It's doing its best to make it all work. So we're going to try and help it be a bit smarter. You see, this gap here doesn't have to be 114. In fact, we don't even want 114. What we really want is 30 to match this thing. So it's 30 there and 30 here. But we don't need exactly 30. You know, on iPhone 6, there could be loads of white space at the bottom. iPhone 4S, we just want a little bit to make sure it matches the top spacing. Now, right now, this constraint is set to be equal. If you select it here, I've just chosen that flag and clicked its constraint, it says relation equal, which means it must be exactly equal to 114. We can change that to be greater than or equal. You'll see a little greater than or equal sign now appears inside the canvas, and change that constant to be 30. So it said, listen, there's some flexibility. It could be 1,000, but it has to be at least 30. If you play it back now, you'll see the layout looks different again. So it looks better. The flag is only slightly squished, and it actually imperceptibly squished. If you look at it, I can't really tell. Because it's only a few pixels off at this point. But that gap is now the same as that gap, which is exactly what we wanted. These four gaps are all identically sized. So using greater than or equal has solved the first problem for us. But landscape still sucks. So the bottom flag just resized out of existence, disappeared. The second flag has shrunk down a fair way. It still doesn't look great. So we still have all sorts of problems here. And we can again make that a bit smarter. We can say, listen, we really want to make sure that you don't squish the flags like that, because it's done its best. Again, it's made the Germany flag full size, so at least it satisfied one image correctly, one button correctly. That one is the correct size. The rest, it's made a slight compromise in the Irish flag, and it's totally erased the American flag out of existence. We don't want it to do that. We want to tell it, actually, if you're going to squish the flags, if you have to squish the flags, at least squish them proportionately. Make them all equally squished, which is not great, but it's better. We're getting there. So you can click on the second flag, control drag to the first flag, and select equal heights. What that means is it will match this height with that height. Whatever height that will be, this will be the same. And the same add from the third flag to the second flag. So the second flag has equal height to the first flag. Third flag has equal height to the second flag. And look at all these arrows going on. It's getting more complicated now, but that's all right. Press Command R again, and we'll see what it looks like now. Hello, there we go. So you can see it is maintaining 30, 30, 30, 30. Good. So spacing looks fantastic. and it's now squishing the flags proportionately rather than erasing one of them entirely. So it's kind of better, but it's kind of worse at the same time. Now with one more rule, we can actually stop the flags from being squished ever, because we can ask Interface Builder to maintain the aspect ratio of our flags. So if you remember these things, the size of them was 200 wide by 100 high. Now if iOS using auto layout is forced to reduce the height to 50 to make it spaced correctly inside it, we can ask it to reduce the width by the same amount. So the width become 100, so it's the same proportion, twice as high twice as wide as it is high. And to do that, it's very straightforward. You want to control drag from the first flag upwards and onto itself and choose aspect ratio. Again, more things appear. It's getting really messy now. So second one, control drag from itself, straight up, aspect ratio. Third one, control drag straight up to itself, aspect ratio. So there's now loads of these lines going on with all the auto layout rules kicking in. But we have specified exactly what should happen. So if you click play now, have a look at this. There's our flags, all perfectly sized, all equally spaced, all equally sized. Go to landscape, and boom, they all scale down perfectly, keeping the right spacing, keeping the right aspect ratio, and keeping equal heights. This is all done inside Interface Builder. So now the game that was awful in landscape mode is perfect in landscape mode, just with a few more auto layout constraints. Auto layout is extraordinarily powerful, and this is showing you a small glimpse of it. To show you some more, we're going to switch to code. So what I want to do is leave this behind. That's your new project now. You can either keep this new version with more rules, or go back to the old version. It's down to you whether you want to support landscape or not. Go ahead and just close that thing entirely. Stop running it. Quit the window. Go away Xcode. Finish with you. Let's make a new project inside Xcode. So File, New Project. Choose iOS Application, then choose Single View Application. For the name, give it the name Project 6B. For everything else, it doesn't matter what you do. Swift is fine. Device iPhone is fine. Nothing else here needs to change. Go ahead and press Next and save it somewhere. I will choose my desktop, and it will make the default single view controller template for us, which is perfectly fine. You can go ahead and press play, see how it looks. I'll choose iPhone 5S. Press play. It will build and run the very tedious single view controller project, which is just a blank white screen if you remember. There we go. Fine. We're going to add some code to this, all by hand, all is in code, no more storyboard, because you can do a heck of a lot inside code to handle auto layout. So the first thing we're going to do is create some labels. There's going to be quite a bit of typing here, so you will want to copy and paste stuff. So firstly, let's make a label, which is a UI label. So we'll call this one label 1. So let label 1 equals UI label. Then we'll call a method on it, which is very long. Please use autocomplete. So label1 dot set translates auto resizing mask into constraints. Enter. False. Then give it a background color. I will choose label1 dot background color equals UI color dot red color, like that. And then give it a text, which is label1 dot text equals these, like that. Copy and paste those lines. So we have label 1, label 2, label 3, label 4, label 5. Fantastic. So 2, 2, 2, 2, then 3, 3, 3, 3, then 4, 4, 4, 4, then 5, 5, 5, 5. So we've got 5 labels. And for the text, I'll have the first one, these. Second one can be R. Third one's some. Fourth one, awesome. Fifth one, labels. There we go. So that's our 5 label text. And for colors, let's use red. Let's use some cyan. Let's add a bit of yellow. Let's add some green, and let's add some orange. So there are our labels. Now that creates 5 labels in code, which we can then add to our view, which is done by saying view.add subview label 1, copy and paste, 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 5, 4, 3, 2. So that adds all 5 labels to the view. Temporarily put to one side what that code does. We'll come back to it in just a second. We're going to make one small change just after view did load using a new method you haven't seen before, which is called prefers status bar hidden. Use code completion so it does the whole override func return value bool thing for you, and just put in there return true. All that means is don't show the status bar inside this view controller. It only makes it easier to see what we're trying to do. That's all it is. So let's have a look at what this code actually does. So it creates a label here, new UI label, then it sets this massive long thing to be false. Now, before auto layout existed, there was a thing called auto resizing masks, which is a much, much simpler way of doing layouts, and it kind of worked well enough. Some people fought with it tooth and nail, but it usually worked well enough at basic layouts. But it wasn't smart enough to adapt to various different screen sizes. So it really wasn't going to work in the long term once layouts got more complicated. So fortunately, Apple introduced these auto layout tools to do layout for us much more easily. As you saw in Project 6a, it really is quite amazing. That kind of thing you could not do with auto resizing masks. But by default, anything you add in code has an auto resizing mask attached to it that gets magically turned into auto layout constraints that make it a certain size and certain position. We just want to turn that off. Turn off the magic. We're going to do it all by hand. It's much, much easier to do this. So that line just means don't make auto layout constraints for me. I will do it myself. And that's on all 5 labels. Each one's got different text color, different background color, so you can see what's going on, and then various bits of text throughout so you can see exactly what's going on. So that creates 5 labels, then adds all 5 to the view. If you run the program now, press play and look at the simulator, you won't see very much. You just see labels me. That's what it looks like, which is rubbish. And that's not 5 labels, that's 2 labels at best, right? What's happening is the labels are all being placed at their default position on the screen, which is the top left corner. And they're all being sized to fit their content. So this orange labels here exactly fits the space required to write the word labels. So they all squeeze up to take as little space as possible. Now we're going to start adding auto layout constraints using code. And this is done using a technique called Visual Format Language, or VFL. And VFL lets you do kind of ASCII art. It's like symbols with, brackets and parentheses and that kind of thing. And let you describe your layout by kind of drawing it using letters. It looks strange, but it is so powerful. But it uses a dictionary, which you haven't seen before, of strings and values. So a dictionary, you've seen arrays so far, which are just like when you say var mer is an array of strings, and we want to add stuff to that, so we can do mer equals fizz, then buzz, then wombat, whatever. It's an array of strings that you can read out mer 0 or mer 1 or mer 1000 or whatever you want. That is a dictionary that you can just read into based on number. We want to create, an array, you can read into based on number. We want to create a dictionary here. And a dictionary has a key and a value. You don't look into it, you don't pull things out based on position. You pull things out based on a key. So what you can say is, mer is a string : string, which means the key is a string and the value is also a string. So you can say mer first name equals Paul, or mer age equals, how old am I anyway? Obviously just 21 and not at all 35. But it has to be a string because we said, listen, the key's a string and the value's a string. If you had like equals 35 as a number, it wouldn't accept that because mer only takes strings. And to read values out again, all you have to do is, it's still warning us. Why are you warning us? Why are you warning us? Yes, because we have to create the thing, don't we? Look at that. There we go, much nicer. And then I'll go away. Good. You have to actually create it before you use it, obviously. Thank you very much, Swift. So we're putting things out based on keys. So we can say, var name equals meh first name. So rather than doing meh 0, which is useless, or meh 1001, which is, who knows what that is, we just say meh first name. That's a much nicer way of referring to things. Now, to use auto layout in code, you have to use a dictionary. And it'll become clear why. So let's just go ahead and do it for now, and you'll become clear why in a moment. So do let views dictionary equals, and the dictionary should be the name of the label, label 1, then its value, label 1. Then another name, label 2, then its value, label 2. Then another name, label 3, then another value, label 3. Space there, I think, make it look pretty. Then label 4, and colon, label 4, and finally label 5. Label 5. Fantastic. That is our views dictionary. It creates a dictionary with strings for the keys and labels as the value. And in fact, if you type views dictionary, it'll tell you, look, it's a string for the key, UI label for the value. So it knows exactly what it means. Now, this thing might seem completely redundant, but it is really important inside visual format language. We're now going to add some constraints to our view programmatically using this VFL. It's really powerful stuff. So we'll say, hey view, please add some constraints. There's 2, constraint and constraints. Please choose the plural version. And we say ns layout constraint dot constraints with visual format. I'm going to hide some stuff here so you can see more of my screen. There we go. Constraints with visual format. And we want to provide it the VFL. The visual format, we want to say h colon pipe symbol. That's shift, and for me at least it's shift and backslash. It might be different on other keyboards perhaps, but pipe symbol. Then bracket label 1 bracket pipe symbol quote. That is visual format language. I'll explain what it does in a minute. Options, just type all zeros. Metrics, just go ahead and write nil. And then views, you need to pass in views dictionary, that thing we made a minute ago. That is all it takes to add constraints to the view. So copy and paste that for each of our labels. So 1, 2, 3, 4, 5, and then change here. 5, 4, 3, 2. So 1, 2, 3, 4, 5 all works there. It's a lot of code, but it's actually the same thing, as you can see, 5 times over. So we could, if you choose to, rewrite that using a for loop and some string interpolation. If you like that kind of thing, you can say for label in views dictionary dot keys, i.e. these string names, give me these things. What I want to do is, let's copy and paste that line in there and say view add constraints, constraints visual format. We want to use string interpolation here, so it'll be backslash parenthesis to start string interpolation, then the label name, then end interpolation, and it'll put that in there instead. That'll do the same thing as these 5 lines of code. It's in a loop, so it's fractionally easier to read, particularly if you have more things going on. Otherwise, it's the same. Now, what is happening here? Well, let's look at the easy stuff first. So view.add constraints is a method we are calling on the view. It just adds an array of constraints all at once, all auto layout constraints to the view. It needs to be constraints with a plural rather than just constraint, because VFL can generate multiple constraints at a time, and it will do here when we're using it. Next up, we're using ns layout constraint, constraints visual format method, which creates a new set of constraints we pass in with some VFL. All zeros for options, no special options, no metrics. We'll look at that in a moment, but really, for now, it's good enough. Just go ahead and create it. And all that leaves is this bit, the actual VFL. And so we have, ignoring this fancy pants string interpolation version for a second, we have h colon pipe bracket label 1 bracket pipe quote, which looks like line noise, but it is important. So h colon means we are defining a horizontal layout. This is how it looks going across the screen, not vertically across the screen. We'll do a vertical layout shortly. This pipe symbol here represents the edge of the containing view. which in our storyboard is sort of the edge of the screen, really, because there's not much going on there. So the edge of the screen is that pipe and that pipe. So edge of screen, edge of screen. In between that, we have bracket label 1 bracket, which is a visual way of saying put label 1 there. Imagine these brackets here. They're like a little visual way of drawing the edges of a rectangular view. That's our view there. And this essentially means horizontally, I want my label 1 to go edge to edge in the entire view. But there's a hiccup. What does label 1 mean? Now to you and me, we can say, well, label 1, that's my constant name. I look up here, is let label 1 equals UI label. But that's a constant name or a variable name. When your code's compiled, it doesn't keep these variable names around, it tosses them away. They're for us to read. The program doesn't use variable names or constant names, they're just for us. So what we do is we tell auto layout what label 1 means. We're saying, listen, if you see a view called label 1, what I mean is that object. And when I see a view called label 2, in here, label 2, when you see that, I mean that thing. So even though this line looks utterly redundant, it is important because it's saying that text string means that object, that text string means that object, and so on. So it is important. And that's the entire VFL explained. Each of our labels will now stretch edge to edge in the view. If you run the code now, you should see that if I haven't muffed up the string interpolation. There we go. So it's all running edge to edge. Now you can't see very much. You just see the last one because they're all the same width now, all edge to edge, and all the same height because they're all matching their content. So all you're seeing is the last one. Doesn't look great. So we're going to fix this with a vertical layout. So we've got this horizontal layouts here. I'll just clean this up a little bit. We're going to create a vertical layout. Now vertically, we want these things to stack up. So we don't need 5 separate lines. We can do this all with one line of VFL. So I'll say view.add constraints, again plural, ns layout constraint dot constraint with visual format as before. And the format should be v, because it's vertical this time, colon, pipe, so the top of the view, because you're going vertically now, down from top to bottom, bracket label 1, then dash, bracket label 2, dash, bracket label 3, dash, bracket label 4, dash, bracket label 5. And then quote. There's no pipe at the end. Just leave it without a pipe in the end. Option should be dot all zeros again. We don't want to provide any options at this point. Metrics nil. And then views again, passing the views dictionary so it knows what all these text strings in here actually mean. So that's pretty much the same line of code as before, except now the VFL has changed. It's V colon. It means this is vertical. Kind of tilt it 90 degrees to read this. That's at the top, then that, then that, then that, then that. That's what's happening. And this dash symbol here, that means some space. I want a label, then a gap, then a label, then a gap, label, gap, label. And by default, unless you specify otherwise, that gap, a dash by itself, means a 10-point gap. Remember, points are virtual pixels. That'll be 10 pixels on a non-Retina device, 20 on a Retina device, or 30 on a Retina HD device. So it hasn't got a pipe at the end, because we don't care where label 5 ends up. We shouldn't stretch it to the bottom of the view, which is what it would do if there were a pipe at the end. It'll leave some white space at the end, naturally filling up whatever's there. So if you run the code now, it should look a lot better. Let's just start to be looking correct. There we go. So they're all full width. They're all got this nice 10-point gap between them, and they're all spaced equally going down the way. Portrait and landscape. Auto layout doing exactly the right thing. Fantastic. That is the beginning of code auto layout. There's so much more this can do. So we've got a working layout right now, but it's quite basic. Those labels aren't very high. Without a rule about the bottom of the last label, it's possible the views could be pushed off the bottom edge on very, 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 very small devices perhaps. So to begin to fix this problem, we're going to add a constraint for the bottom edge here, which there isn't one right now. And we're going to say the bottom of our last label must be at least 10 points away from the bottom of the view controller's view. And we're also going to tell auto layout that we want each of the 5 labels to be bigger, specifically 88 points high. Nice and big. So to do that, first up, let's make these labels the right size. So label 1, what you do is inside the square bracket, you write parenthesis equals equals 88, parenthesis, like that. Then copy and paste that to be label 2, then label 3, and label 4, and label 5. So label 1 should be exactly 88 points high, label 2 88, label 3 88, 4, 5, 88 points high. For the gap at the end, we want a gap, but we want to make sure it's at least 10 points high. By itself, if we did something like that, it would mean exactly 10 points, which would go crazy because we know that's against the edge. These are all exactly 88, and then you've got a 10-point gap in the bottom. And if that does not exactly add up to the right number, you've got a problem. With the right number being, let's say, 88 times 5, so 440, with 10-point gaps between them across the way. It takes a very precise device to fit that exact gap. So we don't want exactly 10 points. We want at least 10 points for this gap at the end. So we're going to write parentheses, then greater than or equals to 10. That's our least number. Then another parenthesis, then dash again. So we want this gap here, but it should be at least 10 points, but it could be a lot more. Run that now and see how it looks. Oh, it's crashed. It's crashed because it cannot handle my constraint format. That means I've muffed up my auto layout constraint somewhere because I am obviously quite slow. Let me just debug that quickly and see what's going on. There we go. There's my error there. You see that? That bracket got moved back here by accident because I'm a bit slow. Sorry. Let's try that again. That's how it should look. Do not copy the buggy version. Copy this version. And now run it again. Let's see how it looks this time. Oh, much better. So we have all the gaps in there still. The labels are much bigger now. And there's at least a 10-point gap at the bottom, but it's stretching up to be bigger. So it's looking better. So you're seeing now equals equals, i.e. exactly 88, and greater than or equal to 10, at least 10, but it could be 100 or 1,000 depending on the device. Now, 88, I think looking at it, it looks pretty good. But actually, I think 80 is a better number. So let's go ahead and make this 80 instead. So I'll delete it from there, and delete it from there, and then it looks like it deletes it from here too. And then, whoa, actually, wait a minute. I just got an email on my phone here from the IT guy saying, actually, no, 80 is a terrible size for labels. It should be 64 points high. So, okay, fine, not 80, but 64. 64, and then 64, and then 64, and, wait a minute. Now the IT guy and the design's having a fight over there, and it's got punches going in, and, okay, they've agreed. Yep, they've agreed. They want 72 points high. Fine. So not 64, but 72, 72. And this is extremely tedious. This is not coding. This is just pushing points around. And this is the kind of thing you can get trapped in very easily if your app's being designed by a committee, which is terrible. We can fix this with the power of auto layout. We can make it so much easier to make these kind of mass changes quickly and easily. So where we've got, equal 72 there and all sorts of things going on, we can start to use this parameter here called metrics. Right now it's nil. We can pass a dictionary in there with different metrics that we can reuse again and again and again. So for example, let's say let metrics equals a dictionary where the key is called label height and the value is 88. That's our current size. Of course, after that little fight, they want 72, so fine, we'll put in 72. And now we can pass that into this metrics thing here. So metrics, pass in our little dictionary. And what it means is every time we previously had written equals 72 or some other number, we can just write in there label height, which is the key we gave here. So it means look in here to find the number, in this case 72. So let's copy and paste that in here, and there, and there, and here, and the last one. Run it back now, and let's see how that looks. Yes, clearly 72 is a far superior number, but they can say, actually, no, I want 90. Boom, change it in one place, and all the views update instantly together to be the same size. So using metrics is a great way when your designer, your manager, your inner pedant decides that 88 is clearly the wrong number and it should be something else. So you make one change and see the whole thing immediately. Now, there's a problem here, and we're going to try and fix it, which makes the whole thing much, much nicer. Because right now it is still imperfect. It works perfectly fine in portrait, but in landscape, let's have a look what it does. Well, it's had a good job. It's kind of squashed it here and there, and what's this? Xcode is printing out some horror in my debug area, telling me it cannot simultaneously satisfy constraints. This means it's looked at my rules and it simply cannot make them work. It cannot make all these things 90 high while still making sure there's these gaps between them. There is not enough space in there. And we can fix that because whenever you create a constraint in code or in the interface builder, you get to assign a priority. You can say how important this constraint is to you. Now, by default, these constraints are all required. I want every one of these constraints to be hit. And that's when you get this problem here. I've tried to follow your rules that they're all required. I've tried to make them all match, and I simply can't do it. So auto layout started breaking the rules. It said, listen, I'll shrink that one and who knows what, and it kind of works. But when it breaks your auto layout rules, it basically never gets it right. And that's your fault, not auto layout's fault, to be fair. So we can give our constraints a different priority, a value between 1, basically not important, bottom of the list, and 1,000 is allowable, where 1,000 means required, and anything less than 1,000 means optional. Even 999 is still optional, and it means we can give auto layout some leeway to work around our problem. So in our case, if we make the 88 point height optional, auto layout can shrink them. It could be 70 or 76, whatever it takes to make them to do its best, but it will do its best to get as close to 88 as possible. It evaluates the priorities. It'll say, okay, I've got 10 constraints here, 5 are required, make those happen. Next one's really important, 999, do that one next. Then one's 750 and one's 500 and yada, 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 down to the lowest one. And it will make sure it does the best it can down that list. And it may have to ignore some of the bottom ones because it won't work, but that's okay because they're not required, they're optional. So what we're going to do is we're going to make the labels have a size at a lower priority. Specifically, what we're going to do is when I say label 1, your label height should be at priority, at symbol, 999. This is really important to us that you do your absolute best to match your label height of what we got, 90. But if you can't do it, that's okay. You can compromise. And again, auto layout will compromise as best as it can. It will try and get 88 or 89 or as close as it can to that. But what we're also going to do is really cool. We're going to say label 2, whatever the compromise is for label 1, please use the same compromise. So rather than having label height in here, we can actually say label 1 for the height of label 2. And same for label, undo that mistake. Same for label 3's height. Same for label 4's height, and same for label 5's height. So what this will mean is auto layout will say, okay, find the best size I can for this thing, given that it's not required, it's just very important. But make sure that same size can be used for all of these. So it will divide the space equally between them in a way that gets it as close as possible to 90. Let's run the app now and see how that looks. So at 90 and rotate. Hello, there we go. The spacing is all intact. There's our 10-point gap at the bottom, and they're all matched up. No more errors in the console. It looks fantastic. Nothing's being clipped anymore. So that is auto layout done in code, as well as, of course, the aspect ratio stuff from before in Project 6a. There's a lot this stuff can do. It really is very amazing. I think I described it in the first Project 2 as black magic, and that's what it can feel like sometimes. Of course, it isn't. It's just tons of mathematics being done behind the scenes at lightning fast speed, which is amazing. You will use auto layout a lot It will be your friend eventually. You may have a few constraint problems here and there, but you'll get through them eventually. Trust me, it is excellent when you are at ease with it. So that's a project over. That's another technique project down. You are now fractionally more experienced with auto layout. We'll be using more of it in the future. For more information, please go to the website hackingwithswift.com, where you can buy this video in high resolution format and hear and see on my screen in much better resolution. It helps support my work. Or you can buy this as a book or buy the entire series as a book, which again supports my work and helps me make more videos like this one. Alternatively, follow me on Twitter. I am at 2straws. I can do my best to answer questions, help you solve problems if I have the time. Please get in touch. I'd love to hear from you.